Alright, so we're going to go over the test here, and we are going to start with our Le Chatelier's principle and our KEQ expression. So reaction's endothermic, so heat is a reactant. I'm adding heat, so it's going to shift right. KEQ, products over reactants. Alright, so there's one. B, C is added to the reaction, but C is a solid, so no change because it does not appear in KEQ. Alright, C, the volume is increased. So we have 3 moles of gas over here, 1 mole of gas over here. Be very careful about these state symbols. So if the volume increases, it's going to the side with more gas. So this is shift right. KEQ, liquids aren't in KEQ, so it's O2 squared H4N2 divided by N2O. D, volumes increase. Well, there's no gases. Volume only matters for gases, so no change. Then, let's see, D, A squared, B. D is added. Since D is a product, we'll shift left. Then D, A squared. Both B and D liquid and solid, so we don't include those. Alright, acid, basic, or neutral. NaOH, that's a strong base. So it's basic. Hydrochloric acid is an acid. Alright, iron chloride. Cl, not a base. Iron is a metal, so that's a, well, this is 1 plus. So that is acidic. NH4 plus, that is something we talked about in class quite a bit. That's an acid. I is not a base, so this is acidic. Na is a metal, group 1, so non-acidic. Br, not acidic, so neutral. Kf. K is group 1, so neutral. F, weak base, so this is basic. Alright, so here in problem 3 we have K, Q, and Q. So the first thing we have to do is calculate Q, which is just SO2 multiplied by Cl2, which is 0.250 times 0.050. So just doing that calculation. Sorry, actually getting out my calculator here. 0.25 times 0.05 is Q is 0.0125. K is 0.002. Right? So K is bigger than Q, which means we need to make more reactants. That one is more reactants. Next problems. Alright, given Kp, calculate Kc. So remember, to calculate delta N, it's moles products minus moles reactants for gases. Alright, so here we have 1 for the product, 3 as the reactant is minus 2. So Kp equals, let me just double check that. So it's actually, I did that wrong. Kc equals Kp RT raised to the delta N. Is that right? No, sorry. I don't have my equation sheet in front of me. I'm second guessing myself. Kp equals Kc RT delta N. So Kp is 2.58 times 10 to the minus 3. equals Kc. R was 8.314 times 298 raised to the power of negative 2. So 298 times 8.314. So this is 2477.57 raised to the power of negative 2. Get out Excel here. Do that really quickly. Equals 247757 raised to the power of negative 2. That's 1.62 times 10 to the minus 7. 1.62 times 10 to the minus 7. So Kc equals 2.58 times 10 to the minus 3 divided by 1.62 times 10 to the minus 7th equals 2.58 times 10 to the minus 3 divided by that. So Kc is like roughly 15,000. So 15,836. Right, B confused a lot of people because again, you gotta look at those state symbols, right? So delta N is 2 minus 1. So Kp equals Kc RT raised to the power of 1. So it's 25,000 equals Kc multiplied by 2477.57. Therefore Kc equals, again, let me calculate that, 50000 divided by 2477.57. So Kc is 100. Alright, next one, we are just looking at equations and seeing if we understand our terminology. So HCl is our acid, NH3 is our base. Remember, the conjugate acid compared to the base just gets one more hydrogen. So NH4, then Cl minus. Here, H2O is our acid, OH is our base. I would have been okay with FeOH3 there as your base as well. Your conjugate acid, though, is H2O, and your conjugate base is OH. Iron should not appear here because it is not acting as a conjugate. Right, next one, strong acid-base solution. So this is a strong acid, so that's 0.50 H3O plus concentration. So minus log of 0.5 is pH. So the pH is 0.303. And then we want, and H3O plus is that as well. So we already have two of those. Then POH is 14 minus this, so POH 0.3, not 0.03, is 13.7. Then H3O multiplied by OH minus equals KW, which is 1.0 times 10 to the minus 14th. So OH minus concentration equals 1.0 times 10 to the minus 14th divided by 0.5. I don't know why I keep doing 0.05, so 0.5 there. So 14 negative 10 that divided by 0.5, 2 times 10 to the minus 14th. Alright, so for B, there's two things. One, you are making 2 hydroxyl. So MgOH2 makes 2 OHs. Secondly, you are dealing with OH, not H+. So the concentration of OH minus is 0.50 because it doubles. And it's actually the same math as above then, but it's for pH. Or sorry, POH, not pH. So the answers are reversed there. All right. Here, A goes to 2B. We start with 2.5. KEQ is 252. What's B at equilibrium? A, 2B. So we have 2.50, 0, minus x, plus 2x. So that was the first thing I was looking for. Remember, stoichiometry matters. 2.50 minus x, 2x. All right. Even though it's not true here based on KEQ, we're just going to do that small. KEQ equals 2b squared over a. At equilibrium, 2b is equal to 2x, so that is equal to 2x squared over 250. KEQ is 252. 2x squared is 4x squared divided by 250, 2.50. Multiply each side by 2.50. Okay, so 252 times 2.5. So that's 630 equals 4x squared. Divide each side by 4. 157.5 equals x squared. Square root everything. X equals 12.54. Then this is x, but at equilibrium it's 2x. So we have to do 2 times x is our concentration of B. So 2 times this is 25.1. So that's B. Now, there was another way to get 25 that a few of you did, but unless you showed me the work of 2x going to 4x squared, I didn't count that for full points because you did the wrong method, but you got a similar answer, which means what you did only works out for this specific numbers that I chose. And if I chose any other numbers, if you use your method, you would have got the wrong answer. So that's why if you wrote down like 25, but you still got points off, it's because you kind of lucked into the right answer. And so here we need to show our work to make sure we understand it. 7, HF goes to H plus F minus ICE. Ka equals HF divided by HF, 0.1 minus x, 0.1 minus x again. That's small. 0, 0, x, 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 x. So Ka 2.39 times 10 to the minus 6 equals x squared divided by 0.1. which is 2.39 times 10 to the minus 7th equals x squared. So x equals 0.3, so x is 0.000489. That's our concentration of H3O plus, so I do the minus log of 0.000489. And the pH there is 3.31. Right, for our last problem, this was the problem where I just said you can't actually get KEQ, so just solve for H3O plus concentration. And so we have pH equals 2.20. pH equals minus log of hydronium concentration. So 10 to the minus pH equals H3O plus. So that's what I was looking for. So 10 to the minus 2.20 equals H3O plus. So H3O plus is 0.00631 molar. Right, so that's all I was looking for there, and that was out of 4 points. Originally, I was supposed to give you a starting concentration of that, so it would have been like 0.100 molar again, and you'd have to do this first step anyways to do your ice table. But yeah, that is our exam 3. If you have questions about anything, as always, let me know. Otherwise, I will see you in class.